Okay, we'll get back to section 10.3 here. We're talking about polar coordinates. And let's see, so far we looked at converting a point that was in polar coordinates to rectangular coordinates. That's where I ended the last video with. And so let's look at and it's two examples here. I got part A, part B, of a point that's in rectangular coordinates, and we want to convert that to polar coordinate form. So let's see, if I were to plot this point 1, -1 in rectangular coordinates, I'm going to be in quadrant 4, right? So if I don't get a point in quadrant 4, in polar coordinate form, like something went wrong. Okay, well, so here's the formulas for how to get from rectangular form to polar form. R squared equals x squared plus y squared, and tan theta equals y over x. So I'm going to be using those. R squared equals x squared plus y squared. X is 1, y is -1. -1 squared is 1. 1 plus 1 is 2. So r equals plus or minus the square root of 2. Okay, now I'm going to choose r to be a positive number. You can choose r to be a negative. It's going to affect your answer though. We'll see why shortly here. So what if r is root 2? Okay, again, I got to land in quadrant 4 here. So tangent theta is y over x. Y is -1 and x is 1. So tan theta equals -1. So what angle is the opposite side -1 and the adjacent side 1? Well, that's going to be when theta is -π/4 or 7π/4. That's the same thing, right? There's infinitely many answers I could give here. Suppose that theta is -π/4. That's going to put me in quadrant 4. Okay, tangent of -π/4, that's -1. So one answer that you could give would be root 2 -π/4. Okay, another answer that you could give, so because -π/4 is the same as 7π/4, you're just going counterclockwise around the origin there. Another answer that you could give is root 2 7π/4. That would also be acceptable. Okay, or like here we're choosing r to be a positive. Like, what if r is a negative number? Again, I got to land in quadrant 4. So 3π/4, that's going to put me in quadrant 2. But if r is a negative, I'm going in the opposite direction. So that'll put me in quadrant 4. Okay, so another answer that you could give here would be -root 2 3π/4. Let's take a look at this problem next. So suppose that we want to change up the point -1 -root 3. That's going to put us in quadrant 3, right? So I got to make sure I'm landing in quadrant 3. Well, x is -1 and y is -root 3. So when I plug that in the formula here, r squared equals 4. Means that r is plus or minus 2. Again, I'll take r to be positive 2. It's okay if r is a negative. Just got to make sure that you're landing in the correct quadrant there. So again, I need to make sure I'm landing in quadrant 3. Well, tan theta equals y over x. So negative over negative is positive. Okay. Now, I need to look at this as -root 3 divided by -1. Okay, so the opposite side is -root 3. The adjacent side is -1. And that's going to put me into quadrant 3. Tangent of 4π divided by 3 is negative over negative. That's going to put me into quadrant 3. So one answer that I could give here would be 2/4π/3. Okay, but 4π/3, that's the same thing as going clockwise around the origin there. -2π/3 radians would also put me at the same radial line as 4π/3. Okay, so another answer I could give here would be 2 -2π/3. Another answer that I could give is if r is negative, Again, I need to make sure I'm landing in quadrant 3. So the angle that's opposite for pi over 3 would be pi over 3. Okay, so if I go out, on the pi over 3 radial line, but r is a negative 2, so I'm going to go in the opposite direction. That's going to put me in quadrant 3. I'm going the opposite direction 2 units. Negative 2 pi over 3, that would also be an answer. And there's infinitely many answers that I could give here. Just you got to make sure that you're in quadrant 3 and land in the right spot there. Here's another example. There's a couple of questions like this. We want to find a Cartesian equation for the equation r equals sine theta minus cosine theta. Okay, so what's this look like in terms of x and y? Okay, well, if we multiply both sides of this equation by r squared equals r sine theta minus r cosine theta. R squared, that's the same as x squared plus y squared. R sine theta, that's the same as y. And r cosine theta, that's the same as x. Okay, so x squared plus y squared equals y minus x. That would be my answer. That would be the Cartesian equation, or the equation in rectangular coordinates. Okay, the next thing that I want us to do is we get some practice sketching some graphs, okay? So I've got, looks like 12 equations. These are all in polar coordinates. And it says that an equation whose variables are polar coordinates is called a polar equation. Okay, so these are all polar equations. And I want us to graph each polar equation, okay? I have this grid here. These are called polar grids. So again, there's major axes and there's minor axes. The 0 radian axis, the pi over 2 radian axis, the pi axis, and the 3 pi over 2 axis, those are all major axes. And then the minor axes would be like pi over 6, pi over 4, pi over 3, ones that still come up a lot, but they're not one of the 4 major axes. And with a polar grid, you have infinitely many axes coming out from the center. Okay? Now with the rectangular grid, there's only 2 axes. There's the x-axis and the y-axis, so that is a difference between the two. All right, now the first 6 problems are going to go very quick. The last 6 problems are going to take some more time. So suppose that we want to graph r equals 3. Okay, well, if I square both sides in that equation, r squared equals 9. R squared is x squared plus y squared. So I got x squared plus y squared equal 9. That'd be a circle, which is centered at the origin, and the radius is 3. Okay, so I need to go 3 units out on each of these axes and plot a point. And I get a circle. But by the way, it does not matter what theta is. Theta can be anything. R is always 3. Okay, so we end up getting the circle of radius 3. In problem 2, we got theta equals pi over 4. Okay, so if I take tangent of both sides, tan theta equals tan pi over 4. Tan pi over 4 is 1. And let's see, tan theta, that's the same as r sine theta over r cosine theta. So then if I multiply both sides of this equation by r cosine theta, I got r sine theta equals r cosine theta. And the reason why I did that is because r sine theta, that's what I'm calling x. R cosine theta, that's what I'm calling y. So in other words, I need to graph the line x equals y. Okay, well that's a line flowing through quadrants 1 and 3, in rectangular form. It is not going to matter what r is. R can be any number. Theta is always going to be pi over 4. So here's, if I go out 1 unit, go up to pi over 4, plot a point. If I go out 2 units, go up to pi over 4, plot a point. R can be a negative, right? So here's negative 1 pi over 4, negative 2 pi over 4, right? And I end up getting this line. In problem 3, I got the equation r sine theta equals 3. Okay, well, r sine theta, that's by definition y. So I need to graph the line y equals 3. Well, that's a horizontal line at a height of 3. Okay, so I'm going to come up and make this horizontal line y equals 3. Again, y equals 3 is the same thing as r sine theta equals 3. Now, there's a couple of questions in the book about, which equation looks easier to write. Okay, well, y equals 3 for this one, right? Y equals 3 looks like, is less writing and if I had r sine theta equal 3. Okay, although r sine theta equal 3, that's the same thing. In problem 4, we got r cosine theta equals -2. Okay, r cosine theta, that's the same as x. Okay, so really I'm graphing the vertical line, x equals -2. Okay, so I got my polar grid. Here's the 0 radian axis, the pi over 2 radian axis, the pi axis, the 3 pi over 2 axis, right? And go out 2 units there and make this vertical line. So r cosine theta equals -2. Okay, and let's see. So problem 5 is the next one. In problem 5, I'm graphing the curve r equals 4 sine theta. Okay, so the idea is like what do these curves look like in rectangular form? It's gonna be a line or a circle or something like that. Okay, so if I square both sides of this equation, or excuse me, if I multiply both sides of this equation by r squared equals 4r sine theta. R squared is x squared plus y squared. R sine theta is y, so that's equal to 4y. And if I subtract 4y from both sides, and all the terms are on the left there, then the next thing I'm going to do is I'm going to complete the square. Okay, so completing the square is something you learn in algebra class. I'm going to complete the square specifically only on the y terms. Okay, so I got x squared plus y squared minus 4y. And then now how I complete the square is I need to take half of the number in front of y squared. And I'm going to add that new number to both sides. Okay, so half of the number in front of y, half of -4 is -2. And I'm supposed to square -2. -2 squared is 4. So I'm going to add 4 to both sides. Now the reason why I did that, because that sounds like a weird thing to do, but the reason why I did that is because the expression that's inside the parentheses there will always factor. And furthermore, the factors will always be the same. That will always happen. So let's see, I'm factoring y squared minus 4y plus 4. That's going to factor nicely as y minus 2 times y minus 2, or y minus 2 squared. By the way, it is always going to be the number that you're squaring in the previous line if you're trying to figure out the factors. And that's a convenient thing to know, because sometimes when you complete the square, you work with fractions and stuff like that. So because I'm squaring a -2, half of -4 is -2. Because I'm squaring a -2 to get this 4, I'm going to have -2 right there in the two factors. That will always happen, always. So it's like I don't even have to think of it. Okay. And now at this point, I'm done. Okay, I have this equation now rewritten into the standard form of an equation of a circle. So the standard form of an equation of a circle is x minus h squared plus y minus k squared equals r squared. R is the radius. So the radius of this circle would be 2. 2 squared is 4. And the center point of the circle, hk, is me at 0, 2. Okay, so I'm subtracting 0 and I'm subtracting 2. So the center point is at 0, 2, not 0, -2. Don't make that mistake. Okay, so I need to graph this circle whose center point is at 0, 2. So there's the center point. And I just make 4 points kind of hovering around the center, and then I'll draw a circle as best I can. So if I go 2 units to the right of the center, that's going to bring me to this point here, which would be 2, 2 in rectangular form. If I go 2 units to the left of the center, that'll bring me to this point, -2, 2 in rectangular form. If I go 2 units above the center, that brings me to the point 0, 4 And if I go 2 units below the center, that brings me to the origin, 0, 0. Okay, so I can then draw the circle as best I can. Now, if I want to know what like what point this is, because you know, like in polar form, if like here's the center. Okay, if I go 2 units to the right, like where is that exactly? Okay, well, I'm going to be on the radial line pi over 4 and 3 pi over 4. Right, because those are the radial lines that are halfway between 0 and pi over 2 and halfway between pi over 2 and pi. So I need to go out to let's see, R is 4 sine theta, right? So if theta is pi over 4, sine pi over 4 is 1 over root 2. So times 4, that's 4 divided by root 2. If you multiply the top and bottom by root 2, you got 4 root 2 divided by 2. That's the same as 2 root 2. Okay, root 2 is the same thing as 1.4 about. So if I double that, 2.8, it would be the distance that I'd have to go out on the radial line pi over 4, or yeah, pi over 4. So here's pi over 4 units. If I go out 2.8 units, roughly, and then plot that point there, that'd be about right there. Okay? And then do the same thing on the other side. On the radial line 3 pi over 4, I need to go out 2.8 units, roughly, plot that point right there. Okay? And then once I got those 4 points, I can then draw the circle. Okay? Problem 6 is going to be, you know, very similar here. So I got r equals 2 cosine theta. Okay, if I multiply both sides by r squared equal 2r cosine theta. R squared is x squared plus y squared. R cosine theta is x. Okay, and so I'm going to subtract 2x from both sides. And if I group those terms together, x squared minus 2x, then I'm going to complete the square on only the terms involving x. So half of negative 2 squared, I'm going to add that new number to both sides. Half of negative 2 is negative 1. Negative 1 squared is 1. So 1 is going to be the magical number here that I'll add to both sides in this equation. Now the reason why I did that is because this guy here is going to factor, and also the factors are the same, right? X minus 1 times x minus 1, or x minus 1 squared, would be how this factors. Again, it's always going to be the number that you're squaring in the previous line. That will always happen. So because I was squaring a negative 1 to get that 1, I'm going to have minus 1 in the two factors. So now we're all done here with this equation. So this is a circle. Okay, the radius of the circle is 1, and the center point HK, H is 1 and K is 0, is 1, 0. Okay, so I need to plot that point there, 1, 0, and then I need to use the radius to build 4 points around the center. So if I go 1 unit to the right, 1 unit to the left, 1 unit above, and 1 unit below. Now 1 unit above brings me to the radial line pi over 4. Okay, so if theta is pi over 4, cosine pi over 4 is 1 over root 2. So if I rationalize the denominator there, multiply the top and bottom by root 2, I got 2 root 2 divided by 2, that's root 2. Okay, root 2 is about 1.4. So on the radial line pi over 4, I need to go about 1.4 units. That'll put me right there. And I plot a point. Okay? And then do the same thing on the 7 pi over 4 radial line. Go out root 2 units and plot that point. And then once you have the 4 points kind of hovered around the center, you'll then draw a circle as best you can. Okay? So the first 6 problems are, I don't think they're too bad. You know, the remaining 6 are going to require some more work here. So when we hit those in the next video.